Alright, in this video we're going over 8-5 vectors. Alright, so here's your vocabulary. Vector. A vector is simply a quantity with magnitude or size and direction. Okay, magnitude or size and direction. Magnitude, simply the size or length of your vector. Alright, it's a complicated word for something so simple. Magnitude is just the length of the vector. That's all it is. Initial point, it's your starting point of your vector. Terminal point, it's the ending point of your vector. And the resultant is the sum of two vectors. Alright, so pause the video, write these down, make sure these are in your notes. Alright, now, describing a vector. Alright, you can use an ordered pair to describe a vector. Alright, now, when you write the ordered pair that is describing a vector, instead of using parentheses like we normally do, what you're going to have to do now is use the greater than or less than symbols to enclose your coordinate point x and y. Alright, you're going to have to enclose them with greater than or less than symbols. Alright, so let's find the ordered pair for OL. All it is the coordinates of L. Okay? That's all it simply is. Because the ordered pair is simply the magnitude and direction of the vector from the origin. Okay? So, all we got to do is we got to find the coordinate points of L. So, what is vector OL as a coordinate pair? This is how you represent a vector. Alright? You have just a single-sided arrow above your line. And that indicates that your line is a vector. So OL is a vector because we have a single-sided arrow above it. Okay? So now to find the ordered pair, of course, we need an x value and a y value. We know our y value is going to be negative because it's below the x-axis. So we know our y value is going to be negative. Now, just like in the last video, this video you're also going to have to be strong in your trigs, sine, cosine, and tangent. Alright, make sure you remember those ratios. Again, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Alright, so for this one, let's go ahead and find x. Well, x is your adjacent side to the 50 degrees. So we know that the cosine of 50 degrees is going to equal adjacent over hypotenuse. If you notice here, the length or magnitude of our vector is the hypotenuse of our triangle, because this makes a right triangle. Alright, so to solve this, you're going to multiply both sides by 65. So 65 times the cosine, times the cosine of 50 degrees is going to equal x. So punch this into your calculator. 65 times the cosine of x is 41.8. So that is our x value, 41.8. Alright, so again, to find x, we use the cosine because in relationship to our 50-degree angle, x is the adjacent side because it physically touches the angle. So we're using cosine, adjacent over hypotenuse. So cosine of 50 is x over 65, multiply both sides by 65, and we came down and found x to be 41.8 rounded to the nearest tenth. Alright, so now let's find y. Which trig function are we going to use to find y? Hopefully you said sine. The sine of 50 degrees, alright, the y is the opposite side from the 50, so it's opposite over hypotenuse. So again, multiply both sides by 65. So 65 times the sine of 50 degrees equals y. So y equals 49.8. Alright, now it's 49.8. But you have to realize that this is in the fourth quadrant. All right, it's below the x-axis. So our y value is going to be negative. So this is negative 49.8. So this is the ordered pair, okay, that describes our vector. So all we did was we used our trigonometry that we learned back in 8-3. We made this into a right triangle. We took our angle and the length of our vector and solved for our two side lengths using sine and cosine. That's all there is to it. Now, part 2 of describing a vector. Now, when you describe a vector, you have to do two things. You mention the angle, and you also mention its direction. Direction that corresponds with a compass, north, south, east, and west. So for our first example up here, if you notice, we're 25 degrees below east. Or we're 25 degrees. Since we're below east and going below east, we're going south. So we are 25 degrees south of east. 25 degrees south of east. Since we're below east, we're going toward the south. Now, if we had done this angle here, we would have been that many degrees east of south. So if we did this one here, let's see, this has to equal 90, so this would be 65 degrees. So now this 65 degree angle would be 65 degrees east of south. You see the difference? It all depends on where your angle is. If you're coming down from east, it's south of east. If you're coming up from south, it's east of south. So, pause the video, take a few seconds, see if you can figure out the correct naming for this angle. So, since this angle is 35 degrees, we know it's going to be 35 degrees something. Well, if you notice, we're coming off of north, so we're going toward the east. Since we're going toward the east, this would be 35 degrees east of north. You see that? It'd be 35 degrees east of north because your angle is coming off of the north side. Okay? It's coming off of the north part of the compass, so it's 35 degrees east of north. If it had been this one, which would be 55. Now, that angle would be 55 degrees north because you're going toward the north of east. So, your first direction is whatever this arrow is pointing at. Since this arrow is pointing at south, it's south of wherever it's coming from, so south of east. But if we flipped it, since this is pointing toward east, then your first direction is going to be east, so it's east of where it's coming from, south. Same thing here. Since this is pointing toward the east, it's east of north. Since this is pointing toward north, it's north of east. Make sense? Let's work on a problem real quick. An airplane lands 40 kilometers west and 25 kilometers south of where it took off. This trip can be described by the vector -40, -25. What are the magnitude and direction of its flight vector? Basically, you need to find the magnitude of the vector, so you need to find this side. And remember, this makes a right triangle. So when you have two sides of a right triangle, how do you find the third side? So basically, you're finding the length of this side, and then you're going to say, well, and you're going to find the degree of the angle, and then you're going to say it's this many degrees, like north of east or something like that, whatever this one follows. So pause the video for a minute and see if you can figure this out. All right, that should have been enough time. So now, the easiest thing to do is going to be to find C. Because since this is a right triangle and these are our two legs, we're simply going to do negative 40 squared plus negative 25 squared, and that's going to give us C squared. Then we're going to take the square root of it. So 40 squared is 1600. 1600 plus 25 squared is 625. And we're going to take the square root of that. So it's going to be the square root of 2,225, which is approximately 47.2 kilometers. So C here equals 47.2 kilometers. So first thing done, we found the length or the magnitude of the flight vector. Now we have to find the direction of the flight vector. How do we do that? Hopefully you said trig, because now we have to find the measure of angle x. Now, since this is a decimal and these are whole numbers, well, let me rephrase that. Since we found this number and these are the numbers they gave us, using the numbers they gave you will be more accurate than using a number you found. Because say you made a mistake finding this number. That mistake is going to throw this angle off. So, since they gave you these numbers, let's use these numbers to find the measure of angle x. So, from x, we have the opposite side and the adjacent side, so we're going to use tangent. So the tangent of angle x is going to equal opposite, which is negative 25, over adjacent, which is negative 40. Negative over negative becomes positive. So the tangent of x equals 25 over 40. I would just leave it like that. I would not try to reduce it. I'd just leave it alone. Now remember, when you're trying to find the angle, you have to use the inverse trig. So do second tangent to bring up tangent to the negative 1 of 25 over 40. Just go ahead and type this straight in. Hit the equal sign, and that will give us x. So the inverse tangent of 25 over 40 is approximately 32 degrees. So this is 32 degrees in here. So now we found the magnitude and we found part of the direction. Remember, the other part is we need to say is it east of south, south of east, south of west, and so on. So that's what we have to figure out now. So we know we're 32 degrees. Now remember, what is this arrow pointing at? Well, this arrow is pointing at south. So that's our first direction. South of, where does it start? Well, it starts at west. So south of west. So our final answer for our magnitude is 47.2 kilometers. And the direction of our flight vector is 32 degrees south of west. Alright, there's one more thing I want to go over. This is the easiest thing when it comes to vectors. Adding vectors together. So when you add vectors together, so if we have vector A, which is x1, y1, and vector C, which is x2, y2, to add A to C, so A plus Z, and remember, this is your resultant. All right, that was one of your vocabulary words. The resultant is the sum of two vectors. So the resultant of A and C is simply x1 plus x2, comma y1 plus y2. So you just add the x's together and add the y's together. We've done that before. That's not too bad. So here we have A, which is negative 4, negative 3. Here we have vector C, which is 1, negative 2. What's the resultant of vector A and vector C? Well, you're simply going to go negative 4 plus 1, comma, negative 3 plus a negative, so minus 2. Do the math, and that's your resultant vector. Negative 4 plus 1, well, that's negative 3. Negative 3 minus 2, well, that's negative 5. That is the resultant. You simply add the x's, add the y's. It is really that simple. So, this has been your 8-5 vectors video. I can't think of vector and not think of Despicable Me with, Vector, the criminal. So, anyway, this is your vector video. You can watch this as many times as you need to. Make sure when you come to class tomorrow, you're ready to work some problems. See you tomorrow.